All right, thanks again for having me here to talk about this topic. I want to say before I start, septic systems are not really my area of expertise. I know you can ask me anything you want about water treatment, but if you do have technical issues about how, or technical questions at the end about how septic systems work, if you could email those to me, that would be helpful so that we can collaborate with the actual experts on that topic and answer your questions correctly. Before I get into this topic, I want to talk a little bit about why WQA is interested in this. So why does WQA care what happens inside the septic system? This comes down to the fact that there are millions of people who rely on private wells for their drinking water source. Many of those folks are also relying on on-site wastewater treatment systems, septic systems for the wastewater recycling, and many of those folks are also relying on softeners to either remove hardness or to remove radiologicals and other contaminants. So we need to make sure that these systems are working in harmony. So this quest started for us really in the 70s. There was anecdotal cases coming forward where there's a failure of a septic system, there's a softener discharging into the septic system, and then the softener would tend to be blamed. And so it was an important issue, an issue that needs to be understood. So why would softening cause a concern in a septic system? To understand this conversation, I need to give you a little bit of information about how softeners work. So this slide shows you a representation of the resin beads that are inside the softener tank. When those beads are fully regenerated, they have sodium. So they're attached to a sodium. And the calcium comes in, the big bully calcium guy, and the resin bead actually has more affinity for the calcium and the magnesium than it does for the sodium. So the calcium comes in, kicks the sodium off, the sodium's discharged. Then we need to regenerate. Eventually the capacity of this bed to absorb hardness is used up, so we need to regenerate. So the way that we regenerate a softener is we simply reverse the equilibrium. We flood the system with sodium chloride, and that reverses the equilibrium. If you remember back to your chemistry days, flooding it with all those sodium atoms actually forces the big bully off of the resin bead. So the calcium gets kicked off, and the resin is left fully regenerated with calcium. So the bottom line here is that you have this, while the softener is working, while it's removing hardness, you have this discharge of sodium. And when it's regenerating, there's two things happening. First, you have this water usage because you're regenerating. And second, you also are discharging chloride. So, because part of the salt is sodium, part of the salt is chloride. So there's a chloride discharge. So WQA's objective here, since the 1970s and still today, is we want to shed light on this issue so that we can understand exactly what's going on inside that septic system, and so that if there is a problem that's being caused by the interaction of these two products, that we can seek solutions so that these systems work in harmony. Early on, we decided that we needed to pull in NAURA to this conversation. If you're not familiar with NAURA, NAURA is the National On-Site Wastewater Recycling Association. So they are the association for the septic system industry. So if you want to know about septic systems, those are the folks to pull in. So we pulled them in early on. So does softener discharge negatively impact the performance of a septic system? The common theories that I want to talk about here are hydraulic loading, toxicity, and percolation. So these are the most common ones, but there's some others too that we'll touch on. So first with hydraulic loading. What we're asking here really is, does the flow rate and the volume of discharge from softener regeneration have an effect on the settling and the flotation process, causing carryover of the solids into the drain field? So this slide looks at the actual regeneration process for a typical softener. The first step is typically a backwash. It's the purpose of the backwash is to fluidize the bed. It's regular water. It's not brine at this point. You're fluidizing the bed. The flow rate is around 2 gallons per minute. So in terms of the flow rates during the regeneration process, this is one of the high flow rate events, but really it's 2 gallons per minute. It's not really that high of a flow rate. The brine draw is typically the next step, and I do apologize, my slide here is incorrect on the actual flow rates. I think I got my scale slightly off. The flow rate for the brine draw should be around 0.5 gallons per minute. This is where we're actually pulling that salt into the resin bed and flooding the system with those sodium ions so we can kick the calcium and magnesium off of the resin. And then the next step is a slow rinse. And again, that should be 0.25, I believe, and I have it incorrectly sort of estimated there at 0.5, but I meant to portray 0.25 gallons per minute. So it's a longer rinse, it's a very slow flow, and the purpose of this, again, this is just regular water. We're trying to rinse everything out that was still in the bed due to regeneration. And then finally, we have a fast rinse, which again fluidizes the bed and just does that final rinse of the regeneration chemicals out of the bed. And again, that last step is 2 gallons per minute. So takeaway here, the point I want to make is, in terms of hydraulic loading, the flow rates here are pretty small. And the flow rate for the brine draw itself is actually diluted by these other higher flow events that are not using the brine water. So it's an important thing to understand when you're talking about a softener regeneration and how it works. So NSF looked at this topic. This is NSF International, but formerly known as the National Sanitation Foundation. So at some point they changed their name, but in this case, I'm going to call them NSF International because that's what they are today. So they looked at this topic in 1978. And I'm just going to read you the finding from this is from their executive summary. The volume of softener waste, which is about 50 gallons per regeneration, are added to the septic tank slowly and are not of sufficient volume to cause any deleterious hydraulic load problems in septic tank systems. In fact, they are lower in volume and rate than the addition of waste from automatic washers. So the next topic I want to talk about is toxicity. And this gets down to, we need to understand, is the salt brine discharged from water softener regeneration toxic to the bacteria in the waste treatment system? So again, this was looked at by NSF International. This table here shows the conditions that they studied. They looked at various levels of hardness from 5 grains to 30 grains, so some pretty hard water, various levels of TDS, and they also looked at various levels of discharge, up to 150 gallons of discharge. And their conclusion from this study, NSF International research test undertaken in response to a request from the Ohio Department of Health, confirmed that water softener waste effluents actually exert a beneficial influence on the septic tank system operation by stimulating biological action in the septic tank and cause no operational problems in anaerobic or aerobic on-site wastewater treatment systems. So we'll touch on that again. I'll come back to that topic, but they actually noticed a slight beneficial impact of the discharge. So the next one that I mentioned was percolation. And this comes down to whether or not the water softener regeneration discharge reduces the percolation of water through the soil in seepage fields. So does it cause swelling of the soil particles and prevents percolation? This topic was looked at by the University of Wisconsin. They determined that water softener regeneration waste do not interfere with septic tank system drain field percolation, but actually could improve soil percolation in fine textured soils. And I also want to stress here that if you have later studies showed that if you have a soil drainage field that is really high in clay, that can be an issue. It's going to be an issue anyway, but adding a softener certainly isn't going to help you. So it's something to keep in mind. At this point, you might think, well, that's the end of the story, right? We've talked about all this, and this must be over. But, the anecdotal cases continue to come up, and this continued to lead to new research. So I want to go through some of those other studies which were done subsequent to all of that. This is the Hussein and Litchfield study. It was a quantitative analysis of the impact of salt on microorganisms in aerobic wastewater treatment systems. They exposed the systems to 5 to 10 times the normal brine conditions as a worst case scenario, and they found there was no statistically significant differences in the metabolic activity of the microbial community. The Spratt and Grimesfeld study. This was water quality changes in conventional on-site wastewater treatment systems associated with the use of sodium-based water softeners. It was in 2005. Some of the significant findings here: the addition of softener regeneration waste reduces the potential sodium stress on the septic tank, so we're starting to see a little bit of maybe explanation of why there was some of these beneficial things that were noticed. And the addition of regeneration waste to the septic tank does not cause an increase in TSS concentration and may result in reduced TSS. And the density of typical domestic wastewater does not change significantly with the addition of regeneration wastewater. And finally, the elimination of regeneration wastewater from septic systems may be detrimental to the satisfactory long-term operation of conventional on-site waste treatment systems. So again, another study that indicated there may be some detrimental impacts of diverting the softener discharge. And when we talk about diverting, what's actually happening in some states is there are either local or even state rules that require the softener discharge to be diverted to, say, a French drain, or sometimes even to a driveway. So this one here was a Canadian study, Kinsley, Crolla, and Joy in 2006. This was a field evaluation study. A couple of the significant findings here. No significant differences were found in indicators of tank performance, including septic tank effluent, COD, CBOD, total suspended solids, E. coli, sludge volatile suspended solids, and the sludge and scum accumulation rate. Also, water softener backwash discharge to septic tanks had no significant effect on the biological or physical functioning of the septic tank. So in 2005, NAURA and WQA decided, well, there's been a lot more work that's been done on this. We're still hearing these anecdotal cases. So let's get together, talk about this, and maybe we'll learn something new. So that led to this symposium in 2005, which was jointly hosted by NAURA and WQA. Essentially, we got all the researchers together, we had them present their findings, talk about what other research they thought needed to be done, and see if we could learn anything new. Unfortunately, we didn't really learn anything new from this symposium, but it was a great conversation. Ultimately, that led to a second workshop that was hosted by WRF. At the time, they were called WRF. Now they're called the Water Research Foundation. But they hosted a workshop in 2011, and it was titled Water Softener Research Needs. But really, it was primarily focused on this issue, the issue of what is the impact of softeners on a septic system. NAURA and WQA, again, participated in unfortunately, much of the conversation centered around factors which had already been studied, so neither of us really learned much new from any of that. But there was one unique concept that came out of this workshop, and that was this idea that studies of municipal wastewater systems indicated that the monovalent to divalent cation ratio, if that is not kept within optimal ranges, then solids, proteins, and bacterial polysaccharides will disperse and carry over rather than flocculating and settling. So the idea was, well, if it's happening in the municipal systems, could it be happening in the septic systems? And might that explain some of these anecdotal cases that keep coming forward? So this actually prompted the Virginia Tech study, which occurred in 2013. This study was by Dr. Novak and Hogan, and it was titled Changes in Septic Tank Effluent Due to Water Softener Use. And this idea of looking at the monovalent to divalent cation ratio, or that what they called the M to D ratio, was one of the key focuses of this study. Their finding from this study was the addition of regeneration waste with minimal sodium aids in the settling of solids and therefore may result in a better quality effluent. Such minimum sodium levels are similar to discharge from an efficiently operated softener. So we did again have this finding of, okay, there's a beneficial impact, but now at least we had some science to explain the mechanism. So there's really two ways that you can get this M to D ratio out of whack. One is you can bypass the discharge to the septic system. So you're essentially you're denying the septic system access to calcium and magnesium, which is typically one of the most common divalent cations in the water supply. So you're really changing the chemistry there in the septic tank. The other way is that you could have, say, a vacation home where you have a softener and it's on a timer. And you leave the home vacant for 9 months to a year and a half. That softener is sitting there on the timer regenerating. It's doing nothing but throwing salt into the septic tank. So now you're flooding the septic tank with just the monovalent sodium ion, and you're not giving it any calcium magnesium because there's no other water to use. It's just the softener sitting there. So those were a couple of the findings that came out of that study. Is you want to keep this M to D ratio in the optimal ranges for septic system performance. That ultimately led to this joint guidance document from WQA and NAURA, which is titled How to Maintain a Septic System Receiving Softener Discharge. There's 5 main points to this document. I do have a couple of handouts that summarize the 5 points, but I'm just going to go through at high level what those 5 points are. The first one, all on-site wastewater systems require a degree of user vigilance and periodic maintenance to ensure proper functioning. Should seek guidance on this from state and local regulatory agencies, operation and maintenance manuals of the treatment components, or through a qualified local service provider. So this is really written for the benefit of the consumer, providing guidance for the consumer. The second one, maintain your water softener on a regular basis. Follow the manufacturer's operating instructions and consult or retain a qualified water treatment specialist to assure most efficient softener operation. Numbers 3 and 4, avoid the use of excessive bleaches and detergents, strong disinfectants, every flush toilet disinfection chemicals, and caustic drain cleaners. Be sure to inspect your home for possible sources of excess water consumption, such as leaking, toilet flappers and valves, which can over time overload the septic system. So again, this is just kind of generic advice for a septic system in general, but still important. And then lastly, consider using equipment. By equipment here, I'm talking about softener. Consider using a softener that's determined to be high efficiency or demand-initiated regeneration as opposed to a timer system. And make sure that the salt settings correspond to high efficiency ratings. So bottom line here, key takeaways in terms of the interaction between the softener and the septic system. The key takeaways for WQA and NAURA so far, based on all the science that we've been able to find, is that both of these systems, the septic system and the softener, require maintenance. It's important that you follow those periodic maintenance procedures. And number 2, the softener should be properly configured for efficient use. And that's important beyond just the septic system. It's something that we drive as important through WQA across the board, because the more efficient the softener settings are, the less salt the consumer is going to use, the less environmental impact there is overall. So with that, I'd be happy to take any questions. And I also want to add, the NAURA and WQA were actually, the timing of this is fortuitous, because NAURA and WQA are in the process of looking at this issue right now, and we're actually trying to find if there's any new research out there. We haven't found anything that's been done since 2013 that really advanced the science further than where Dr. Novak left it off. But if you guys are aware of new research on this topic, please email it to me so that I can share that with our collaborators at NAURA.
All right, thank you, Eric. Okay, so there is a question, and I actually have a question. Actually, all of a sudden, there's 3 questions. So the first one, I think maybe people misunderstand. It says, if there aren't a problem, how come almost every major aerobic treatment unit company says to bypass their units? We're talking about anaerobic septic systems, right?
So there are these special aerobic, they call them advanced treatment units, I believe.
Candace talked about that
Candace
yesterday.
talked about them yesterday, yeah. And many of them do recommend bypassing their system. So they recommend take the softener discharge, put it on your driveway, send it to a French drain. And really, the question of why do they continue to recommend that if there isn't any science? That was the whole point of the science to begin with, and that's the reason that NAURA and WQA really wanted to understand this, is could we come up with a scientific explanation for why they feel that way? It comes down to, again, those anecdotal cases.
Okay, so since water softener discharge is not gray water or black water, does this need to be an issue? Why send it to the septic or sanitary lines?
In other words, why not just send it to your driveway, right? And I do realize that, we put salt in our driveways in the winter to melt the snow. But what happens when it rains? All that salt goes directly into the stream. So, the reason that we would prefer not to discharge them directly under the driveway, one is because as soon as it rains, that's going to go right into the stream directly, as opposed to it would at least go into the ground, and it could eventually end up in the groundwater, but it would be not a direct discharge into your stream. But more importantly, it creates more cost for the consumer. So really, if there is nothing to this, then the people that are being harmed by all this is really the consumer, because they're the ones who are paying for all of this extra plumbing.
Okay, so any research on RO and septics?
I have not seen any research on RO and septics. The thing about an RO system is it's not going to, if you imagine that the RO system was not there, you're going to have the same water quality going into the septic system as you had without it. So you're going to take some of the water, you're going to remove some contaminants, and then you're going to recombine it all in the end, because you're combining the drain water along with the treated product water. And let's face it, we flush most of our treated water down the drain anyway. So we spend a lot of money to treat water to a high quality, and then we flush it mostly down the drain. But in the end, the RO system isn't adding anything. So if you look at it in terms of the mass amount of any sort of contaminant that would be hitting the septic system, it's going to be the exact same mass that it would be with or without the RO system.
Okay, and last, does promoting efficient lower salt operation imply that salt does have a potential negative impact?
Yes, salt has a potential negative impact on our environment. Chloride is not good for streams and lakes, and we need to do our best to try to prevent as much chloride discharge as we can.
Or groundwater, actually.
Or groundwater, absolutely.
We see in the Chicago area, in Illinois, a lot of elevated chloride levels in our shallow groundwater. So, yep. Okay. That's the time we have. We're going to let that go. It just came up. All right, so thank you.